Assalamualaikum. Assalamualaikum. Today we would like to talk about the types of motion, which is chapter 7. Alright. Today I would like to talk about forms of motion. Right. Most human movement is general motion and a complex combination of linear and angular motion components. Right. Both are pure forms of motion, which is useful to break complex movement down when performing an analysis. Alright, let's talk about general motion. General motion is involving a translation and rotation simultaneously. They have linear motion and angular motion. Linear motion is a long line that may be straight away and a curve. Angular is involving rotation around a central line or point, which is like cycling. And linear motion is also referred as translatory motion or translation. They have rectilinear and curvilinear. Rectilinear is a line or straight, and curvilinear is curve line. Right. Next, we talk about angular motion. Angular motion is a rotation around a central imaginary line known as the axis of rotation. They have involved rotation and around on axis. Right, that's all for the forms of motion. Okay, right now we would like to talk about the kinematics of projectile motion, which is projectile is a body in free that is subject only to the force of gravity and air resistance. This example is like we throw a golf ball to the people. Another example is basketball, discus thrower, high jumper, skydiver are all projectiles as long as they are moving in the air without assist. Right. Right now, we like to talk about the horizontal and vertical components. Vertical is influenced by gravity, whereas no force affects that horizontal component. It relates to the maximum height achieved by the projectile, and horizontal component is the motion relates to the distance the projectile travels. Right. Once body has been projected into the air, it means like when you throw something into the air, its overall resultant velocity is constantly changing because of the force acting on it. Alright. Horizontal and vertical component of projectile motion are independent of each other. Example like a ball hit horizontally has the same vertical component as a ball dropped with no horizontal velocity. Alright. Now let's talk about the influence of gravity. Force of gravity is the major factor that influences the vertical component of projectile motion. Gravitational force is constant, and unchanging force that produce a constant downward is vertical acceleration. Right. The acceleration of gravity is treated as a negative quantity, which is negative 9.81 meter per second. This acceleration remains constant regardless of the size, shape or weight of the projectile. Okay. Right now we will talk about the apex. Apex is the influence of gravity on projectile flight in the case of a ball tossed upward into the air by a juggler, which is apex is mean by maximum height in projectile motion. Right. Right, now we talk about the factors that influencing projectile trajectory. They have three factors, which is the angle of projection, which like the angle of projection is the degree of your example. It's like 45 degree. And next is projection of speed, and lastly is relative height of projection. Right. For the projection of angle, is the direction at which body is projected with respect to the horizontal. And if the projection angle is oblique at angle between 0 and 90, the trajectory is called parabolic. It's mean like shape like parabola. Alright. Projection angle is in projection situation on field. A resistance may, in reality, create irregularities in shape of projectile trajectory. Projection speed. When projection angle and other factors are constant, the projection speed determines the length or size and the projectile trajectory. This combined effect of projection speed and projection of angle on the horizontal displacement or range of the projectile. Range means by the horizontal displacement of a projectile at landing. Alright. The last is relative projection height. The third major factor influencing projectile trajectory is the relative projection height. Is the difference between the projection height and landing height. Right. When projection velocity is constant, greater relative projection height is translated to longer flight time and greater horizontal displacement of the projectile. Alright. Now we talk about the lastly is optimum projection condition. This is the factor of that varies the most, both with the event and the performer, is the optimal angle of projection. Alright, when relative projection height is 0, the angle of projection that produce maximal horizontal is displacement is 45 degree. As relative projection is height increase, the optimal angle of projection decrease, and as relative projection height decrease, and the optimal angle is increase. Alright, that's all from me for the chapter 7, and thank you.